Hello and welcome. In this video, I'm going to show you how to model an air heater in ANSYS Fluent. In our model, air flow into a heater, and due to applied heat flux, the air temperature increases. In this study, we only use a 90-degree section because of symmetric bounding condition. Now let's get started modeling. For the side model, select Fluent, right-click on Geometry, select New Design Model, change unit to centimeters, click on Z-axis, select XY plane, and select New Sketch here and click on sketching, select a rectangle. Okay, now click on dimensions. The H1 is 20 centimeters and V2 is 3 centimeters. Okay, now click on create and click revolve. Okay, for the axis we use this edge. Okay, and now click on apply. For the angle we use 90 degree because we have a symmetry bounding condition, and now click on generate. Okay, it is our domain. Now close this window. Right click on mesh and click on edit. Click on mesh and click on generate. Okay, we need to increase our number of elements, so click on mesh and here click on element size and we use. Okay, now we want to create inflation, so right click on mesh, click on insert and select inflation. Okay, select the body, and in this section we need to define our surface. Okay, because it is a no slip boundary condition, so we want to create some inflation here. Now click on generate. As you can see, we created some boundary layer here, so we can modify them. So click on inflation here. As you can see, we need to increase the number of layers. So also we need to define the first layer thicknesses. So we use 0.0001. Okay, and now generate again. Okay, now we need to define our boundary condition. So select the surface, we select this surface, and it is our inlet boundary condition. So here we insert inlet. Okay, and now for this boundary we use outlet. This is our heat flux, so here we use heat flux. Okay, and finally we have two surface because this surface and also this surface are symmetry, so we need to define the boundary asymmetry. Okay, so here as you can see we have inlet, outlet, heat flux, and symmetry boundary conditions for our model. Okay, now back to mesh and click on update. Close the mesh, and now here right click on setup and click on edit. We use 5 solar processes, and now click on start. In this example we have a steady state simulation, so here for the time we select a steady, and also we can activate the gravity and we use minus 0.81 for the gravity. Okay, now let's mount to models, and here we activate the energy equation, so click on OK and click on viscous, and here we use chi-epsilon equation, and now click on OK. Click on materials and click on fluid. Here as you can see we have airflow, so we do not need change the fluid. So now let's mount bounding condition for the inlet bounding condition and double click on it. Our velocity is 2.5, and now click on thermal, and our inlet temperature is 300 Kelvin. Okay, click on apply and close. Now select wall. So as you can see here, we have heat flux boundary condition. So double click on it, click on thermal and heat flux. Here we have 1000 watt per square meters for heat flux. So now click on apply and close the window. Okay, now click on initialization and click on initialize. Okay, now click on run calculation. Here we use 200 number of iteration, and now click on calculate. Okay, the run has been completed, and now we want to check our result. So close the Fluent, and now right click on result and click on edit. Now click on contour and click on OK. So here, for example, we're going to check in the symmetry boundary condition. Okay, so now we're going to check the velocity distribution in these surfaces. So here we change velocity. Okay, so click on apply. It is our velocity distribution in symmetry boundary conditions. So here we can increase the contours, for example 100, and now click on apply here. Okay, now we want to check the temperature, so click on temperature and click on apply. It is our temperature distribution. As you can see, the temperature distribution or the thickness of the boundary layer or the thermal boundary layer increases as the length of the air heater increases. Okay, now we want to check outlet temperature, so click on calculators and select function calculator, and here we want to check outlet temperature, so select the average and select outlet boundary condition, and here we select temperature. Now click on calculate. It is our outlet temperature. Okay, thank you for watching the video.